Oh yes, once again, the back science education consultants are back with Senior 5 Pure Mathematics. Lesson 3, Trigonometry, and we are continuing with the important notes that we had begun with. A simple recap of what we said and what we studied in the previous lesson. We ended with a simple table. And then there was a question that was asked, what do you observe from the cosine, the sine, and tangent of each angle with that of its equivalent angle? And we had such angles, 45 degrees, where we found that its equivalent was 315 degrees. We had 150 degrees, which had an equivalent of minus 210 degrees, and so on. What did you find from the sine of this and the sine of this, the cosine of this and the cosine of this, the tan of this and the tan of this? For the good students who did the work, some have sent via our mails. Actually, for those ones who have not yet known, when you do the work, you send either on WhatsApp or on email. Our email addresses are there on the side. And then you don't forget to subscribe to our YouTube channel. Subscription is actually free of charge. You just need to tap there, just a tap like this, and then you always be notified of anything that we post there, so that you keep following. Anything we are giving is free of charge. Please subscribe. So for those ones who sent their work, majority are sending through the WhatsApp. They answered and they told me that the sine of 45 was equal to the sine of 315. The sine of 150 equal to the sine of that, as well as their cosine and the tangent. Therefore, we can end and conclude by saying that actually those angles which you are saying are equivalent. It comes in the sense that the ratios of their trigonometrical ratios are also similar. We have to move on. What do we do next after doing that? We can have a third important note. And the note is a circle drawn with the center at the origin of, divides the coordinate axis into 4 equal parts. And those parts are called quadrants. It's an important note number 3. There you go. We are saying that this circle drawn in the center at the origin, this is our center at the origin, divide the coordinate axis into 4 equal parts called quadrants. These are the 4. This equals that, equals that. And they are named beginning from this positive x-axis, also like we saw in the angles, following the anti-clockwise direction. As when your father produces children, they say this is the first born, second born, third born, the fourth born, fifth born. So this is the first, this time not the first born, but the quadrant. First quadrant, second quadrant, third quadrant, fourth quadrant. I can just say this is the first quadrant, this is the second quadrant, this is the third, and that is the fourth quadrant. And we want to make a comprehensive analysis of the trigonometrical ratios. I know some of you are taught that all scientists take chemistry in your O level. Something like that you remember. Today we want to prove it. So we want to make a comprehensive analysis of the trigonometrical ratios terms of their signs in their respective quadrants. Comprehensive analysis. And this is how we do it. We are going to draw a circle. Then when we divide it, this is x, that's y. Then we are going to consider a certain angle, theta. We are going to consider a certain angle, that is our theta. This one. And we shall also consider the same angle, this other side. Okay? And we shall, if this one, of course, this is the radius of the circle. So this one is making an angle of 90 degrees at this point. I think you can see that we are making some right-angled triangles. This is the same angle theta. And anything, when you remember numbering, anything after here is positive, coming this side is negative. Anything in this direction is positive, then this direction is negative. So meaning this one is a positive value. You can say this is a positive y. But here it is below the x-axis. This is a negative y. Remember, this is the radius. This is negative y. And this is positive y. This one is positive x. And this one is negative x. We want to consider the first quadrant. And we know the value of the sine, the cosine, and the tangent. First quadrant. I say this analysis is a comprehensive one. First quadrant. What is sine theta? Remember that sine is opposite of hypotenuse. The first lesson. So sine theta is opposite of hypotenuse. The radius is always positive. So it is a plus y over an I. And a plus out of a plus, it will be a positive. What is cos theta? Adjacent of hypotenuse, which is a plus x out of I, which gives it a positive. And what is the tangent? Opposite over adjacent, plus y out of plus I, which is a positive. We can check. Let's do second quadrant. Second quadrant. I would request you to do it quickly, but let's do it together. What is sine theta? Our theta, opposite over hypotenuse, plus y over I. This is positive. What is cos theta? Cos theta, adjacent of hypotenuse, minus x over I. A negative out of a positive is a negative. What is tan theta? Tan theta, opposite of adjacent, a plus y out of a minus x, which gives us a minus. What do you realize? In the first quadrant, sine, cos, and tan are positive, all the three. In the second quadrant, it's only sine that is positive. You have a simple exercise to do. And that exercise is to show us which trigonometrical ratio is positive in the third quadrant and the fourth quadrant. That's your activity. When that one is well done, feel free, send on our contacts. We are back, and when you give us your answers, we shall be back and we shall explain whatever is required. Just subscribe. It is just free of charge. Just subscribe. I'm saying subscribe to Back Science Education Consultants, and please tell a friend, inform a friend, so that they can even tell enemies to subscribe there. Thank you very much.